All right, so with D, if you tried to factor this, you wouldn't be able to factor it easily. So that's where the quadratic formula becomes important when we get non-integer solutions. So we already have it in general form. So we know that A equals 1, B equals -4, and C equals -4. So I'm going to substitute in the parts I have. X equals the opposite of B, so +4, plus or minus the square root of -4 squared minus 4 times A times C all over 2 times A. So let's start the simplification process. I have 4 plus or minus -4 times -4 is 16, and then -4 times -4 gives me another 16 over 2. So this gives me 4 plus or minus the square root of 32 over 2. Now, square root of 32 is not a perfect square. So I need to figure out how to simplify my radical. So I'm going to do it over to the side. So 32. I can simplify that to 16 times 2. Now, I could stop there and say, oh, that works out because I know the square root is 16. But just to verify it, I can change that to 4 times 4, which makes it a little bit easier for people to see. So this is the same thing as saying 4 plus or minus the square root of 4 squared times 2 over 2. And the square root of 4 squared means this is plus or minus 4 the square root of 2 over 2. All right, this is an accurate solution, but I want to see, can I simplify? And when I'm simplifying, I'm looking at all three values here. All three of them have to be divisible by the same number. It has to be the whole numbers. The radical gets left alone. It's the three whole numbers in the plus or minus. In this case, all three of them are divisible by 2. So I can say 4 divided by 2 is 2. 4 divided by 2 is 2. I'll leave my radical alone. And then 2 divided by 2 is 1. So it's a whole number. So I can say that my two factors are 2 plus 2 the square root of 2 and 2 minus 2 the square root of 2. Now that's a lot harder to verify. So one of the best things to do at that point is to graph it, see what this is approximately as a number, and then just double check that when you graph it, it crosses the x-axis at about that value. And for both of these, they will work out. So both of them are solutions. In this case, the easiest thing to do, use Desmos, graph them, and just double check that they are at that approximate value.